Welcome to lesson 2, tectonic processes and hazards. Focus of today is to start looking at the plate margins, often known as convergent, divergent, and conservative. This leads on from the previous lesson where we looked at the Earth's structure and the internal forces moving plates and this theory of plate tectonics. As I said in lesson 1, although I'm covering the key content here, I'm doing it in a slightly different order. So if I just activate the marker pen, looked at that in lesson 1, identified that that's the key focus that I'm going to be doing in the next couple of lessons. So I'll go through this idea of divergence in today's lesson, the next one convergence, look at then conservative, and I'll also cover hotspots, sometimes known as magma plumes, and this notion of intraplate earthquakes. These are the things that are away from the plate boundaries. If you look down here, I've covered this already. Okay, and this bit here, the operation of processes at different plate margins, I'll be combining in to here. And so therefore you'll be able to answer a question, say for example, where you have to assess the type of plate boundary and the resultant landforms and events that take place. So again, today's lesson, this word divergence. Sometimes students get confused, and it can be confusing because in the textbooks they'll do a couple of things. They'll often use the word constructive plate margins and divergent. Divergent is a description of the movement. So if you think the word divide, what's happening is the plates are moving away from each other, right? Therefore, it creates room for magma to come up, cool down, solidify, and form new crust. Therefore, construct new crust. So there, hence is the word. So I would say pretty much divergence is synonymous with the word constructive, but you do need to be aware of it. So in the exams, you don't get fazed by it. What's that mean? What's that mean? The first one I'll go through is where two ocean plates move apart, that type of divergence, where we get the formation of ocean ridges. And then the one that we don't tend to do as much, certainly at GCSE, but you definitely need to know at A level, is this where two continental plates move apart, and that creates different landforms. At the end of the day, this slide will go through probably more information than you'll actually utilize in any exam question, but as I said before, I don't just want to teach to the spec, and you never know which piece of information you'll latch onto, but we'll go through the key fundamentals. So the one that's most classically known is this divergence here, ocean. It's not ocean coming to ocean, it's ocean moving away from another ocean, this one this way, and that one that way. And I'll repeat this a few times. The classic one of this is the Mid-Atlantic Ridge, and its very name, ridge, you can see it sticking up. This is a huge feature, which I'll talk more about in subsequent slides. There are others, but this is the go-to one, good example to know, where the North American plate is moving away from the Eurasian plate. And on the next slide, you'll see it going back to a previous animation I've used before on seafloor spreading. So again, just if you can familiarize yourself here, we've got the divergence. We have the ridge, which is about 2 kilometers above the seafloor, still with ocean above it, and it creates a whole set of interesting features. And here we've got this idea of simplicity, this nice, almost like parallel line. In reality, it's not like that, and it creates all this wonderful undersea world of volcanoes and volcanoes, all different sorts of shapes and sizes. And here, what we've got here, for remember, when the plates move apart, magma that comes up from the mantle moves into this position. A lot of it's obviously deflected either side. And then as we get towards this ridge area here, it cools, solidifies, and forms new crust. Okay. The magma that comes here is coming directly from the mantle, so it tends to be of a hotter temperature, flows a lot more. So you get a different set of features than you would at a destructive margin or convergent margin. And then just sort of illustrating a little bit more statically, a bit more simplicity. There's that ridge again there, magma coming up, ocean above it. And you see this divergence, and your convection cell will be working here, And here we have we have seafloor spreading aided by ridge push, and then we have slab pull pulling the plates back down into the mantle. So goes the theory. And here we have the example here. This line here is the Mid-Atlantic Ridge. Again, the movement of the plates is roughly in this direction. And you see that this is not a straight line, it curves round. It's much more intricate than you'd imagine. And then you can see it's quite grey either side here. I think the widest point of this is about 3, maybe 4,000 kilometers wide. There's about 60,000 square kilometers of undersea mountains, many of them which used to formerly be volcanoes. So already we're starting to say it's not just a ridge, it's not just straight. You actually have a whole range of landforms that have formed because of this. So if you look more specifically, as the plates move apart, magma can come up, okay, cools and forms new crust. Remember I said a ridge that can be 2 kilometers high, but periodically magma will break its way through to the ocean floor and erupt as undersea volcanoes, classically known as shield volcanoes, where the magma rises up, quite molten, less in silica, and continuously erupts, can form these huge shield volcanoes. Many of them then, when they become extinct, just become undersea volcanoes, as you can see in the picture here. And then some of them are up long enough to form islands. So there's an element of Iceland being formed this way. Other types of volcanoes, you get fissure eruptions, which are like giant tears in the sea floor where magma spills out. And you get even interesting features like pillow lava, amongst other types of lava being formed. If we look here, this is actually a place that you can go to Iceland, where you can see the North American plate here and the Eurasian plate here. It's a place to go and visit. On this one here, there's that ridge. You notice that the line is kind of punctured by this sort of staccato-like formation here. So rather than being a nice linear pattern here, what this would probably imply is that the consistency, the strength of the crust is stronger, weaker in places. So therefore it breaks, moves maybe slightly quicker, and you get this differential movement. Also maybe some of the movement, the magma underneath, the consistency of the magma is not going to be exactly uniform, so maybe slightly more stronger driving forces. So therefore you get the plate moving at slightly different speeds, and it creates, I suppose you could call them like tears, but they're actually fault lines called transform fault lines, and that creates another landform. But also it creates tensional force, which can lead to earthquakes. So divergent plate boundaries, constructive margins, are synonymous with earthquakes as well, but they usually are mild because the crust itself is quite weak and the tensional forces rarely build up to create high magnitude earthquakes. And again, just reiterating some of the landforms. There's a ridge. What we don't see here are the volcanoes. You don't see the transform fault lines. Again, you see the key movement. And the sea would be here, the ocean. On the next slide, I go through more specifics. So I'm not going to read through this. You can obviously pause the video, look at the PowerPoint slide, and you can get some more specifics in here. What I would do though is practice it. You know, the only way you're going to get this information into your head, like I can do, is to practice, to make it like that script very clear in your head. Practice it enough, and then when you get into the exams, you find you can utilize the bits that you need to answer the question. Just a couple of things here. That should say 60,000 square kilometers. So there's the height, there's the width of the actual, that's the Mid-Atlantic Ridge, and a few things there. Okay. Now, moving on to the second divergent, it's not said it on their divergent boundary, where two continental plates pull apart, move apart. This is less commonly studied, and it does lead to different features and intensity of volcanic eruptions. So again, it's something that you need to be aware of, but again, you don't need to know it in masses of depth. So this one here tells you where you can get them in the world. I'm purely just going to focus on the East African Rift Valley. As you can see here, when the continental plate does move far enough apart, it does lead to the development of a new sea or ocean. You'll see that with the points that I go through. So this is the place that I'm talking about. This part of Africa is splitting away from the rest of Africa. You see it a little bit more accurately here in these two maps here. Now, the essence of this is where, if we look at this plate moving that way and that way, rather than magma coming up initially and just filling in the gap, the plate itself thins. And it's a bit like, I suppose, blue tack when you pull it apart very carefully. It kind of goes thin and a bit vellus-like. It kind of sags down the middle, or chewing gum, or plasticine, something like that. You can demonstrate it, especially if you warm up the blue tack plasticine. And if you pull it slowly apart, it kind of gets thinned and it sags down the middle. And then eventually magma can work its way up, break through, intermix with that thinning crust, and then you get volcanoes. These volcanoes are often known as rhyolitic. That means they are particularly powerful because the magma that's formed is quite viscous, and I suppose that's due to the magma underneath mixing with the melting of this continental crust. Some examples. Now with this one here, there will be slight little bit of repeat what's going on here. And again, you can see here with a very small picture, plate moves that way, that plate moves that way. You can see it's dropped, thinned, whatever you want. There's like a globule of magma coming up, and that breaks its way through the crust as it weakens and then breaks into the surface, creates volcanic eruption potentially. Now, you can see the rift. The rift is that gap, that dip. Now, if we go into the next slide, we can see something slightly more complicated happening as the two plates move apart. So we said they kind of move apart, it thins and allows a volcano to erupt. And as it thins, you can see that dip, that's the rift. But the reality, as it does thin, you can see it thinning here, as this moves apart, we get blocks of the crust, some bits which remain higher, some bits that drop, and so you get this like blocky-like sort of feature, and then the magma rises up. Now, I don't think you need to know the specific names of the blocks, the ones that stick up and the ones that drop down, but you will see that on the next slide, just in case you were interested. So horse and grabens, you can see the horse bits that stick up, and you can see these are sinking down. And that this is obviously theoretical, and this is a little bit more reality. Then moving on to this one here, just to repeat, there we can see the plates moving apart. You can do the extra reading there. As it thins, you can see parts of the crust stick up, some drop down, that blocky-like nature, and you can see the magma starting to work its way up. And eventually it will break through into that crust. So break through into that crust. I realize I just cut across the slides there. And you can see this volcano erupting on the surface. As they continue to move apart, you can see there's water there. Now that would be that for that to take place, water would have to seep in. So you'd have to say by the coastal areas where the rift is, that would open up, go below sea level, or something would break through where water would come through. Would that be gradual, more spectacular? That's for another discussion. But ultimately, that's what you've got. So at the end of this, really what you want to do here is a recap just from memory. You could do this a couple of times. Remember, this is not a test, but doing memory retrieval is so important. Write down what you can remember ocean to ocean divergence. So plate movement, the types of plates, the landforms, any events that take place, and think about the processes. And that should just be like what you guys call a blur. It's like, what can you remember in some sort of organized way? And you can do that really, really scruffily. Once you've done that, and this will be in the booklet, produce two of these, one for the ocean to ocean divergence and one for the continental to continental divergence. And you put a basic picture labeled and annotated, label the key landforms, processes that you need to remember, and then you've got this narrative here that you could paragraph that you might insert. The only place you can insert this would be into a 12 marker, so it's likely to be maybe one paragraph's worth of writing. Okay, so that's the end of that particular lesson. So just to recap, that's one of the plate boundaries. the divergent boundary, ocean to ocean, continental to continental. Next lesson, lesson 3, I'll look at the convergent boundary where you get the destructive landforms. There's 3 of those, one which is a collision zone. Okay, thanks for listening. I'll see you next lesson.